what do we have here?
Oh yeah, before I forget, actually shoot, never mind. We can Wednesday night we have I have baseball right after school. Like I go to push to work out, and then we have practice from 5:30 to 8:30.
Okay.
So I don't think I'll have an opening.
Okay, let me go ahead and cancel that now.
Okay, cool.
Thanks for letting me know
Yeah,
early.
for sure.
Okay,
Yeah,
cool.
cool.
All right, let's see.
All right, sweet.
Shall we start with 26?
Yeah, let's do it.
Okay, what is 26?
So we have to find a common denominator.
Okay,
Um, so that would be 4 as a common denominator.
okay.
Hold on. And then it would be 2 and then 1. So it'd be 3/4, 7 and 3/4 for that one, right?
Again, 7 to the 3/4.
Good. 3/4, yeah.
And there's a
It's,
difference, Dylan.
yeah, they're
This,
completely different.
this is 7 and 3/4.
Yeah.
This is 7 to the 3/4 power.
Yeah.
Okay,
Yeah.
all right.
Okay.
And how about 27?
And then 27. So again, we have to find a common denominator. Um,
No,
so
no.
or do you just,
Only have to find common denominators when you're adding and subtracting.
oh, okay.
In this
All
case,
right.
you're going to be multiplying.
Oh, okay. That makes sense. So this would be 9 to minus 6/12.
Which reduces to,
1/2 minus 1/2.
yeah. And let's talk about that. I just cannot recommend this any more highly. When you're doing that multiplication,
Uh-huh.
don't do it 6 over 12.
No.
Cancel.
Yeah, you cancel the
Now,
3's and then it'd be minus 2/4, which is minus
well,
1.
you don't even have to do 2 over 4. You can cancel that. Make that 1, make that 2.
Yeah, that
And
makes
now
sense.
you immediately get 1/2, and you don't have to deal with any number bigger than 4.
Which saves a bunch of steps.
Well, it's just always better to deal with small numbers if you can. So
Okay.
always simplify when you're multiplying.
Okay.
Okay?
Cool.
Same thing on 28.
hmm
So what are we going to do on 28? You got
Um,
choices. You can solve 28 by 2 different methods.
yeah.
Which one
Um,
work the best?
well, the 6 and 3, that could cancel out and make it 2, right?
Okay, yeah.
Okay.
In
And
other words,
then,
you could do 2 things. We could do this first,
hmm
but that would involve us finding a common denominator.
right.
Whereas if we do the double exponentiation first,
hmm
then we end up with this.
Okay. Oh, okay. Well, how did you get so?
See the advantage
I
of
see.
doing
Yeah.
the multiplication first.
Okay. Cool.
In other words, you don't have to deal with finding a common denominator.
Yeah.
Only because 6 times 1/3 is a whole integer,
Uh-huh.
and 6 times 1/2 is a whole integer.
Yeah.
If you make that a 7, well, then it's not quite as advantageous. In other
hmm
words, now you might as well find a common denominator and
Right.
add them first.
hmm
But always know you can do it in either order and do it in the order that is the easiest.
Okay. Sweet.
29.
29, would that just be 4 and 1/2? Like when you subtract them, or
Yeah.
yeah.
So
Okay.
that's your answer?
Yep.
No?
4 to the 1/2 power.
Okay.
Yeah.
I'm going to keep calling you on it. I don't know what else to do.
No, I appreciate that. Yeah, because I need to get the terminology down.
Well, you do. That's.
Yeah.
I tell you what, that's one difference between online tutoring and regular education,
For
is
sure.
that it forces you to verbalize it properly.
Definitely.
How about number
Yeah.
30?
Okay. When you divide 75 by 15,
Which is
6,
5. Okay.
5. Yeah. So would that be just 5 and 1/6? 5 to the 1/6 power?
Yeah.
Okay.
About 31.
Um, so we could use, well, 2 to the 5th power times 5 to the 2nd power.
Good. So that's only part of it.
Yeah, no, yeah.
But you figured, you figured out that it made sense to do the multiplication first.
Uh-huh.
Of course, we
Yeah.
really didn't have any choice. In other words, if we tried to do inside the parentheses, we have different bases and we have different exponents. So you
Right.
really can't do anything
Mm,
inside the parentheses, but you can do the multiplication first. And when you
okay.
do multiplication, it's pretty nice. What's 2 to
Yeah.
the 5th?
Um,
In other words, now we're not quite done, although
yeah.
they might actually accept that as an answer.
Yeah. It'd be 32
Yeah, 32
and
times what?
25.
Okay. And whatever,
And then
that's
whatever.
got to be 800.
Yep, exactly.
Um, all right.
Yeah, that's exactly 800.
All right.
Alright.
You know how I did that? Is I had 32 quarters in my pocket.
Oh, sweet.
That was $8.
Okay. Alright, that makes sense, yeah.
Well, you're going to divide, if you have 4 quarters, that's $1, right? If you have 8
Yeah,
quarters, that's $2.
$2.
If you have 12
Right,
quarters, that's $3.
right.
32 quarters would be 32 divided by 4, $8.
Which is 8, yeah.
Yeah.
Sweet.
All right, how about 32? Speaking of 32.
Yeah, so what do we do, 64 times 81?
What's the final answer? 64 times 81 to what?
To the 1/2 power.
Correct. In other words, the square root of 64 times 81,
Mm-hmm.
which is, hold on one second, it's not the
Okay.
same as 64 times 81.
No, it would be 8 times 9.
Yeah,
8 times
exactly. And you can then, you don't really need a calculator for this because you can take the
no.
square root of 64 and 81. So
Uh-huh.
8 times 9, which is 72.
So 72 to the 1/2 power.
No?
Oh, just 72.
It's
Yeah,
72.
because we
In other
already
words,
simplified
if I'm going to apply that
it. Mm-hmm.
to the 64 and the 81,
Mm-hmm.
then I don't need to take the square root of the product. In other words, I'm already taking the square root of that times the square root of that.
Cool.
That's how I get
Okay.
that and that.
Okay.
All right. 33, they get harder.
They do. Um,
Now, hold on a second. That is not 3 1/3.
no, 3 to the 1/3 power.
And it cannot be an accident that this is problem number 33.
Mm-hmm.
Notice 33, 3 to the 1/3 to the minus third. That's
Mm-hmm.
somebody's cruel little.
Yeah. Well, would that just be the -3 and the 3 cancel out, right? So just be
Hold
3 to the
on. How
first.
do you handle double exponentiation? What do you do with
Um,
exponents?
you multiply them.
Okay. Multiply the exponents. What do you get?
-3.
What's minus 3 times 1/3?
Oh, minus 3 times 1/3 is 3 over 3. Minus 2 over 3, so it'd be 3 to the minus 1 power. Am I doing that right? Or
Yeah, you are.
okay.
In other words,
Yeah.
when you multiply minus 3 times 1/3, you get minus 1.
Yeah, so,
Okay?
and then
Now,
we'd want to put that over a
multiply
fraction.
that. What is 3 to the minus 1?
Um, 3 to the minus 1 is still 3.
No.
Or minus 3.
1 over 3 to the positive 1. So
Oh, yeah, that's
it's
right.
1/3.
Yeah. Put it
Remember
over a
what
fraction.
negative exponents do.
Okay.
What is 3 to
Yeah,
the minus 2 equal to?
9.
Nope. That's 3 squared. In other words, 3 to the positive 2 equals 9. So there's
Yeah.
no way that 3 to the minus 2 can be equal to 9. What is it equal to?
So it'd be minus 9.
No.
Wait, well.
One thing to remember about negative exponents is that they almost never mean negative numbers.
Okay.
So it's a positive number. It's 1 over 3 to the positive 2. The
Oh,
only
that makes
thing the
sense. You just
negative,
do the
yeah, the only thing the negative
regular
sign
fraction.
means is reciprocal.
Okay,
Okay.
cool.
So that's
Yeah.
why when we had 3 to the minus 1, it meant 1 over 3 to the positive 1, which is 1.
Okay, cool.
All right?
All right, sweet.
34. Now we're
The root.
simplifying radicals.
Yeah.
The trick to simplifying radicals
um,
is finding a factor of that number that is one of your perfect square numbers.
yeah, exactly.
Okay, well, what would that be?
Um,
There's not that many perfect square numbers. Here's the
there aren't.
perfect square numbers. These are the ones you got to know.
Yeah.
And that's probably it. You don't
hmm
have to memorize much further than that. Now,
Okay.
one of those is a factor of 150.
Yeah, I got 25 and 6, so the final answer would be 5 root 6.
There you go.
Cool.
Okay, about 35.
So we have to find the cube root of 80.
Yeah, now on 35, what we are looking for is perfect cube numbers.
Yeah.
Well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. And that's probably all the ones you have to memorize.
Yeah.
So which one is a factor of 80?
Um, oh, dude, no.
Which one of those, don't count 1.
No.
I should not even write 1.
You're
Those are the
fine.
perfect cube. Because you're never going to use 1. You're only going to
Uh-huh.
use the perfect cube numbers greater than 1.
Yeah.
Which one of those 3 numbers is a factor of 80?
8,
Okay. What's the
which is
other?
10 times. So it'd be root 8, root 10. Or just 3 root 8.
Now be careful when you say root 8. That's not
Okay.
root 8. Root
Okay.
8, root 8 implies square root.
Okay.
If you're taking the cube root, then you have to say cube root 8
Okay.
times cube root 10. And cube
Well,
root 8 is a perfect cube number, so that becomes a 2 times cube root 10.
okay.
So that's the way you do cube roots. In other words, you do them exactly the same way as we do square roots, only they're perfect cube numbers is what you're looking for.
Okay.
All right, let me erase those because we have another one.
Yeah.
Hold on.
Oh, you're fine.
This, this eraser has been very temperamental lately. I'm not quite sure.
No worries.
The next one is cube root of 108.
Yeah.
What is a factor of that? Now, notice why I don't have to memorize that many perfect cubes.
Yeah.
Because unless it's a giant number, once you get up to 64, no number greater than 64 is going to be a root of 108, let alone a cube root.
Okay.
Okay? Which of those three numbers are factors of 108?
64.
No, it looks like it,
no,
but
actually.
it's not really. You're close. For a second, I thought 64 was also.
Yeah.
8 certainly is also.
8. Yeah.
No, 8 is not. 8
No.
does not divide into 108.
27 isn't either.
Yeah, actually 27 does. Notice that 27 goes into 108 4 times.
Oh, okay.
So that makes it the cube root of 27 times the cube root of 4.
Okay.
And that's worth doing because we know what the cube root of 27 is. So the final answer is 3 cube root 4.
Okay.
See how I did it?
I think so.
Well,
Wouldn't that
we're looking
simplify
for
down to 2?
factors of 108, one of which is a perfect cube number. Well, we found a perfect cube number right there, 27.
Yeah.
That's 3 cubed. Okay? And
Okay.
turns out that 27 goes into 108 exactly 4 times. So 27 times 4 is 108, and this algebra is valid. The cube root, in other words, the cube root of a times b is equal to the cube root of a times the cube root of b.
Okay.
Always do that. You can always separate it, whether it's square root or cube root.
Okay.
Okay?
Cool. Sweet.
All right, now we're fourth roots. Well, tell me perfect fours. I don't even know what to call these. Perfect quarters?
Yeah.
Not
I
perfect
guess.
cubes, but you know what I'm talking about. What's 2 to the 4th?
16.
What's
And then
3 to the 4th?
81.
All right, that's probably as far as we need to go.
Probably, yeah.
Is one of those two a factor of 48?
16.
Okay, so how can I rewrite this?
So 4 root
Fourth
16.
root?
4th root 16.
Okay.
And 4th root 4.
Good. 4th root of 3 is the other one. 3
right,
times 16 is 48. Okay.
Yeah, my bad.
And then
Okay.
the 4th root of 16 can be converted to an integer. That's 2 times the 4th root of 3. Okay.
How would you get the... Oh, I get it. Okay. Well, okay. Yep, I get it.
All right. And
Okay.
as long as we're talking about roots here, this original problem is the same as writing it like this. That's what the 4th root means, is number to the 1/4 exponent.
Okay.
Okay?
Cool.
If
Okay.
I wanted to write this number, I could write it as 4 to the 2/3 power.
Okay.
In other words, you can eliminate the radical signs. And sometimes eliminating the radical signs makes it much easier to deal with because we know how to deal with exponents. So a lot of times if you eliminate the radical sign, you're just looking at an exponent and you can multiply fractions easy enough. So sometimes that's the solution. All right, let's have a look at 38 here.
Okay.
What's square root 3 times square root 6?
Root 18.
Good.
And then you get root 9, then root 2, so it'd be 3 root 2.
Number 39.
3 root 32 times 4.
Third root of 4
Yeah.
times third root of 32. Now, both of those are irrational numbers.
Mm-hmm.
However,
Okay.
we could actually reduce the third root of 32. What would that reduce to? A couple of
Let's
ways
see.
to do this problem, Dylan. One thing, let's for sure look at doing it this way.
Okay.
That's absolutely valid, okay? So one way is you get the third root of 144,
Mm-hmm.
which is not a perfect cube number.
No.
There's no number cubed that equals 144. But another way to do this problem is, well, I can't do much with cube root of 4, but I can change cube root of 32 into cube root of 8 times cube root of 4. You see why?
No.
Well, it's all I'm doing is factoring 32.
Oh, okay.
32
Okay.
is 8 times 4.
Okay.
Okay, so I can always do that. And what's the cube root of 8?
2.
Okay, so now I can replace that with a 2. So now I have 2 times the cube root of 4 times the cube root of 4. Well, that's the cube root of 16.
Okay.
Okay, so now I have 2
2 to the 4th
root
is 16.
of 16. Cube root of 16, I can factor 16. There's a perfect cube number in there. What is it?
4. No. Yeah, 4.
No, 4 is not a perfect cube number. What are your perfect cube numbers? Start with a 1 and count up.
2 to the 3rd
Is
is
what?
8.
Ah, there's a perfect cube. Is 8 a factor of 16?
Yep. 2 times.
Okay. So now I can turn that into a 2.
Okay.
Now I have 2 times 2. So this is the answer.
Oh, wow. Okay.
Okay. Now, notice that the first way we did it was very quick. When we got to this, the problem is that that's difficult to simplify.
For sure.
I mean, we have to find perfect cube numbers that are factors of 144. We would eventually have done it, but it's a much more difficult problem. By simplifying it first, we never dealt with a number greater than 8. Well, yes, we did. 16, excuse me.
Yeah, 16.
We had 16 there, the cube root of 16. But pretty much we kept it to small numbers.
Okay.
And we still got this answer, which is the same thing as the cube root of 64 times the cube root of 2, which is the cube root of 144.
Okay.
Hold on. It's not the cube root of 144. It's the cube root of 128. How did I do make... No, that's 128, not 144. I did the multiplication wrong. 128, which is even harder.
Yeah.
Yeah. Not really, I guess. I mean, if you know that factors of 128 are 64 and 2, then you get it right away because 64 is a perfect cube number. So eventually you get this, but I think you can kind of see what the difference is. In other words, if I multiply the numbers inside the radical together first, then I end up with a big number. And then I have to figure out how to whittle down that big number. Whereas if I can whittle down this number first, the cube root of 32, then I'm reducing everything. It's very similar to simplifying a fraction.
Okay. Cool. If we could hop down, because I know how to do 40 and 41, so if we could hop down to do 42.
Okay.
Because I'm just confused on how to do the fractions with the 3 in front of it.
Okay. Well, it's really no different.
It's not.
In other words, no, the first thing you want to do here is split it into two fractions.
Okay.
What is it? If I split that up, what's the numerator? What's the denominator? Cube root of 5 is the numerator. What's the denominator?
Oh, okay, and 3 root 2. Or,
cube root of...
Yeah, cube root 2, yeah.
Right. Now, there's a problem with this answer. And that is that we have an irrational denominator that needs rationalized. Now, it's not as easy to rationalize cube roots, but it's easier if you write them as exponents, like this. You'll see why in just a moment.
Okay.
Now, I can multiply top and bottom by anything I want. This is what I'm going to multiply top and bottom by. You see why? When I say anything I want, I mean by 1, the number 1.
Oh, okay.
2 to the 2/3 divided by 2 to the 2/3 is the number 1. Okay? And the reason I want to do that is because I'm going to turn the bottom into what? What is 2 to the 1/3 times 2 to the 2/3?
2 to the first power.
Yeah, that's a rational number.
Okay, I'm just confused, like, why would you multiply, or why would it be 2/3, like, when you multiply it?
You have to make sure the exponent becomes 1.
So...
If it was square root, let's back up. This is an important concept here.
Yeah.
Let's say I had square root of 5 over square root of 2. Well, you'd multiply that by that, right?
Yeah, exactly.
But what if I wrote it 5 to the 1/2 over 2 to the 1/2, which is the same thing? Well, I would need to multiply that by 2 to the 1/2 over 2 to the 1/2 because my purpose is to turn the denominator into a whole number.
Right.
And 2 to the 1/2 times 2 to the 1/2 is 2. So if I have thirds instead, well, in order to turn the denominator into a whole number, I got to multiply it by 2/3 because I'm going to add the exponents.
Okay, that makes sense.
And that turns the denominator into 2 to the 1.
Okay.
So that's my denominator. Now the numerator is, I can't do a lot with that. I have different...
Yeah.
I could do one thing with it.
Wouldn't that just be 10 over 2?
No, it's not 10 over 2. In other words, you cannot add the exponents unless the bases are the same.
Okay.
You can do something with it if the exponents are the same, but they're not. In other words, neither the bases nor the exponents are the same. However, what if I write it like this? 5 to the 1/3 times 2 to the 1/3 times 2 to the 1/3 all over 2. Isn't that the same thing?
Yeah.
Well, now I have 3 bases all to the same exponent. So I can multiply the 3 bases, which becomes 20 to the 1/3. See where I get that?
Uh-huh.
All over 2. That's your answer.
Okay.
That's how you simplify that problem.
That makes sense. All right.
No, I'm not sure how much sense it makes. You'd probably get away with this as an answer also. I mean, this is kind of like factoring it first. And
Right.
once I factor it, then I have the same exponent. And if you have the same exponent, different bases, then you can multiply all the bases together.
Mm-hmm.
In other words, 5 times 2 times 2 is 20.
Yeah.
All to the 1/3 power.
Mm-hmm.
And I still have an irrational numerator, but I have a rational denominator.
Okay.
And that was the only difficulty with the problem all along. In other words,
Yeah.
the only problem with that answer is it's an irrational denominator.
Yeah.
All right, Dylan,
Okay.
I will
Right.
let you go, and we can either finish up this set of problems or some new ones on Wednesday. Oh, no, you're
Yeah.
not going to be available Wednesday. Okay.
No.